Hi, everybody coming in. Just saying hi. How's it going? Hope it's swell.
Hi, everyone.
Hi, Jenny. Yeah, I'm getting texts from everybody who's here and chats saying hi. Yeah, I'm here.
Shall we begin? Hi, all. Welcome to the final ATS ANAH talk. I'm joined here today with Dr. Eugenia Cheng, and we'll be moderating the live Q&A with Amelia Worthington.
Eugenia Cheng is a mathematician, educator, author, columnist, public speaker, pianist, and artist. She is a scientist in residence at the School of the Art Institute of Chicago. She won tenure in pure mathematics at the University of Sheffield, UK, and now honorary visiting fellow at City University of London. She has previously taught pure mathematics. She has previously taught at the University of Cambridge, Chicago, and Nice, and holds a PhD in pure mathematics from the University of Cambridge. She is the author of X plus Y, a mathematician's manifesto for rethinking gender, and recently featured in the New York Times article, "To the mathematician Eugenia Cheng, there's no gap between art and science."
Before we begin, I want to acknowledge members from the ANAH team, Audrey Roy, Stella Kwan, and Justin Guzman for bringing our vision to life. I also wanted to give a really special thank you to Jennifer Dorothy Lee, Laura Lamb, Michael Powell, Nora Taylor, and Judd Morrissey. We remain sincerely grateful for SAIC Student Government, the Department of Art History, Theory, and Criticism, and the Department of Art and Technology Studies who have made the series possible.
First, we'll be watching a video by Eugenia, and after we'll ask and take questions from the audience. Feel free to write any questions you have in the chat as we watch. So without further ado, hit it.
Hello, I'm Dr. Eugenia Cheng, scientist in residence at the School of the Art Institute of Chicago. I am so happy to be giving this talk today, and I would really like to thank ATS and ANAH for inviting me to share this talk with you. And thank you for joining me today to hear me talk about math, art, and social justice. I'm a pure mathematician. And before I came to SAIC, I was a kind of normal math professor in normal math universities. But now, yes, I teach abstract mathematics to art students at SAIC. And I talk a lot about how math helps me understand social justice issues. I've always cared about social justice, and I've always believed that education is a really important key to some things in social justice. But until I came to SAIC, I didn't talk directly about how to use math to understand questions of politics and social justice. And that's what I would like to talk about today, together with my use of math and art to illuminate and raise questions about social justice issues. So here is the plan for my talk today. First, I'm going to tell you a little bit about my story and how I got to where I am now and what it is that I actually do now. And then I will talk about my first art commission, which was at Hotel EMC2 in downtown Chicago. Because actually, before I came to SAIC, my interaction with art was mostly through music, because I'm also a classical pianist and I perform concerts, and I run a salon downtown in Chicago, or at least I did until COVID came along. But I have started making mathematical art, and the first commission was from Hotel EMC2, and I would like to talk about that and talk about how that related to the class I teach every fall at SAIC, which is the Elegance of Abstraction. And then I'll talk about how that led into my next art commission as part of the Living Architecture installation at 6018 North, which then traveled around a little bit. And then finally, I'd like to talk about what I now think about art and propaganda and social justice and political questions. So I'm going to make my picture a little bit smaller now so that it doesn't impinge too much on my slides. First of all, what is, oh, I need to get focus back, my story. Well, as I said at the beginning, I was a kind of normal math professor. I did my PhD in pure mathematics at the University of Cambridge. It's in category theory, which is a very abstract branch of mathematics, supposedly very far away from real life. And I'll talk about how I used to think that my research would only have a very, very indirect effect on real life questions. And now I think differently about that. And the thing is that I used to teach normal math classes at normal universities to math majors. And I was teaching, I got tenure at the University of Sheffield in the UK, and I was trying to find ways to make abstract mathematics interesting to many students who didn't specifically choose to do abstract math in university. And many of them weren't going to go on to become mathematicians. And so there was a big question about how it was going to be relevant, why it was relevant, how to make it interesting. And so my first book came from making math fun for all sorts of people, because I realized that my students in Sheffield woke up the most when I told stories about food. And so my first book, How to Bake Pie, came out in 2015, and it was all about category theory, but how math can be fun, really fun, because you can relate it to food, and it has lots of food analogies and food demonstrations in it. And 2015 was actually the year I moved to SAIC, and this was a dream for me because I had been wanting to branch out beyond just teaching math to normal math students. And so I was looking for ways to do more of that and to do more work in the public sphere, more work in the media, more popularizing of mathematics. And I didn't really find the opportunities I wanted in the UK. So when I wrote How to Bake Pie, it was really my dream textbook for how I would teach liberal arts math if I ever had a chance. And it didn't look like I was ever going to have a chance. At the University of Sheffield, I tried to propose math classes for non-math students, but I was told that that was a waste of our expertise. So I decided to just write the book instead, even though I didn't have a class to teach. And then when the opportunity to teach math at SAIC came up, I was ecstatic, and I thought it sounded like my dream job. And moreover, I had already written the textbook in advance because this book was my dream of how to teach math as liberal arts. So my next book was Beyond Infinity. And although that came out in 2017, both of these two books I'd already written before I came to SAIC. It's just because of the delay in publishing books, they came out while I was at SAIC. And Beyond Infinity is about how math is a journey, it's a process, it's not about finding the right answer, but it was exploring the idea of infinity. And while I was teaching at SAIC, I started to shift, and the shift really happened dramatically during the fall semester of 2016 when some things were going on in the world that I felt were too important not to talk about. And that was, of course, when there was an election. And the morning after the election, like many people, I wept and drank and was depressed. And I thought, what can I do? What can I do to help? Because I always want to say, what can I as a mathematician do to contribute to the world and help it in some way that I see fit? And all through that semester, I had been talking more and more about political questions because it was just too important to ignore. And I'm so grateful because the students in my classes in 2015 and 2016, and still going forward, the students at SAIC have always pushed me and expanded my horizons and pushed me to talk more about social and political questions, because it seems to me that that is what motivates students at SAIC a lot. The food thing, well, it just didn't seem to be quite so motivating. And so I went from talking about math is fun, it's about food, to math is important because it can help us with politics. And it was in the 2016, after the election, I thought, what can I do to help? I thought, well, I can write a book, because I had been developing in class with students, I had been developing more and more ways to address the really difficult social and political questions using the techniques of abstract mathematical thinking. And so that was what my next book turned out to be. I gathered all that material that I had developed in class, and that became this book, The Art of Logic in an Illogical World, where I show how to use abstract mathematics to illuminate those questions, not to win arguments, because this isn't about winning arguments. It's about finding more ways to have productive conversations with each other. And my last book was also about social justice questions, and it was also very deeply inspired by my teaching at SAIC, because when I taught math majors at previous universities, it was extremely male dominated, and it was extremely the faculty was extremely male dominated, and the research world is extremely male dominated. And then I moved to SAIC, and my classes are not male dominated. In fact, I typically have more trans students than cis white male students, and that's a very different experience to me. And so I began thinking about why math is male dominated and how I can learn from my experience of teaching art students to illuminate those questions of gender. And that is what my latest book is about. It's called X plus Y, Mathematician's Manifesto for Rethinking Gender, and that just came out this year. And so through these 4 books, which are all written for non-mathematicians, you can see a progression where I started by just talking about math is fun, and I ended up by talking about math is important and crucial for how we think about the world around us. And that is all thanks to the discussions I've had with students at SAIC in class. And I truly believe that teaching at its best is a two-way process. It's not just someone standing at the front transplanting knowledge into students' brains. Everybody learns from everybody else. And this progression, I think, shows how much I have learned and developed while teaching at SAIC, and I'm enormously grateful for that. And as I've learned so much about it, I want to share it as widely as possible, which is why I've been writing these books. So I first want to talk about what I think mathematics is, so that everyone can try and understand that I'm not talking about mathematics as in numbers and equations. I believe that pure mathematics is a framework for agreeing on things. It's a framework for how we decide on what counts as true. And this is so important in the world because there seems to be a complete inability of people to agree on how we even decide what counts as true information. And we can see this at the moment right now in the aftermath of the election, with opposing sides completely unable to even agree on what the framework is for deciding what the outcome was. And this is a very, very dangerous situation for the world to be in. And I used to think that pure mathematics was very remote from real life and didn't have much to say about it. And applied math is traditionally the part that is thought of as being really related to life. And I agreed, and I thought that there was this very narrow view of how pure mathematics could be related to the world, which is that pure math, the kind I do, is directly useful to applied math. And applied math is useful to science, and science is useful to engineering and medicine, and that is very useful to some part of the world, the quantitative part of the world, that is governed by numbers and equations. But the thing is, that's a very narrow view of what math does. And it gives people an opportunity to say, I am glad that some people do that kind of math, and I hope that everyone is glad that some people do that kind of math. But it gives people an opportunity to say, I am never going to go into those fields, and so I don't need to study math. And this could be true of most students at SAIC, because students at SAIC are not going to become engineers and doctors and go into the quantitative world. And in fact, when I started teaching at SAIC, everything was kind of flipped the other way, because students who become math majors often say, I really like math because it has clear black and white answers and it's got right and wrong. And then I would need to persuade them and point out that actually math at higher levels is not like that. It does not have clear black and white answers. It does not have clear right and wrong. What it does is explore different worlds in which different things can be true and figure out how we're going to decide what counts as true. And in that sense, pure math isn't about understanding numbers and equations and applying that to solve problems in the real world. Pure math is about how to think. And I think every academic discipline gives us a way of thinking more clearly. And as a result, it is about the entire human world. That is, the part of the human world that thinks. Sometimes it seems like not all of the human world is thinking, but wouldn't it be great if everyone could think more clearly? And this is how I teach pure math at SAIC. It's about how to think clearly, how to protect yourself from being manipulated by people who want to manipulate you, and how to understand the human world better. And in that sense, I don't think that there is a big difference there isn't a clean line between pure math, applied math, science, and art and the arts, because we're all surely trying to understand the world around us better. And we have different emphases about which aspects of the world we're trying to understand and how we're going to present our understanding of the world and how we're going to communicate it with other people. And that's what I've been thinking about more and more, because I don't think it's enough to just study and understand the world. We need to communicate that understanding to other people. So that's what I'm going to talk about. And this part of my story started with a surprise email from the Hotel EMC2 in downtown Chicago, which is, of course, a tribute to the equation E equals mc squared. And Scott Greenberg, who owns the hotel, wrote to me out of the blue and asked me to make mathematical art installations for the meeting rooms in the hotel. The hotel is a tribute to art and science. And I honestly thought that this email was some kind of a scam, because it was so unlikely that a hotelier would write to a mathematician asking them to make art commemorating the mathematics of Emmy Noether. For a start, I didn't even know any non-mathematicians who had even heard of Emmy Noether, who is a very famous pure mathematician, but whose work, like most pure mathematicians, isn't really known outside mathematics. But this was written up in the Scientific American and various places. I've included the screenshot here. And the thing that Scott Greenberg said to me, well, I think he thought that because I was at the Art Institute, I must be an artist. But I didn't think I was. I was a mathematician. I am a mathematician, and I'm a pianist, a classical pianist. But he reckoned I could make art to draw people into the world of mathematics without anyone having to understand it in advance. And when I thought about it and talked to him about it, I realized that I did think I could do that, because actually a lot of my work in category theory is very abstract and is very visual. And we use visualizations to understand the abstract structures and also to communicate them with people. And so here is one example of a calculation or a picture I've drawn for a recent research talk, which is to do with my research and calculating something in higher dimensional mathematics. Here is another diagram from my research. This is a quite famous pentagon in higher dimensional mathematics, and it's also something that I do in my class, The Elegance of Abstraction. And if you're in that class, we will get to this in a couple of weeks' time. Here is a page of my sketchbook from the other day, actually. I do all of my research in artist sketchbooks, and this is a page that I drew, which was checking a calculation in some new research I was doing a couple of weeks ago. So first of all, I hope that you're convinced that I don't just do numbers and equations. These diagrams are visual representations of something highly abstract, but I think that the visuals can be very compelling even if you don't understand what's going on inside the mathematics. And that was what I wanted to convey. And that was what the hotel wanted me to convey. They wanted, I mean, this is extraordinary for a hotel of all places. They wanted me to draw people into the world of mathematics using art without starting by explaining the mathematics. And so I did. It was all large chalkboard installations. And so I drew them on actual chalkboards, and then they were photographed and printed indelibly on chalkboard-like material so that they wouldn't wipe off, obviously. So here is one of them, which is a mathematical spiral. Oh, we jumped. Here, this is a mathematical spiral that I drew. So one of the rooms is called symmetry. And so the commission was to commemorate the notions of symmetry. And the other room was to commemorate the mathematician Emmy Noether. So here is another of the pieces, which is what I'm going to talk about quite a lot, because this piece really came from something from inside my class, the Elegance of Abstraction. This is a fractal tree, and this is a knot with some threefold symmetry. Here they all are in a row, so they're actually sliding panels because the audiovisual equipment is behind them. But they're in this meeting room with lots of books around them. And then in the other room, so here is a picture from the launch event. This is the room commemorating the mathematician Emmy Noether, and this has a lot of social justice issues built into it, because Emmy Noether is a somewhat neglected mathematician who really quite helped Einstein develop the theory of relativity. But then it was a very tragic story because she was a woman. So first of all, she was not allowed to fully participate and have a career in mathematics at the time in early 20th century Germany. But then she finally managed to get a very, very small teaching position with the help of Einstein. And then, unfortunately, tragically, she was Jewish, and then the Nazis came along and decreed that Jewish people were not allowed to have civil service positions, and university jobs counted as that. So she was not able to have her job anymore, and so she came as a refugee to the US and got a job here, but then she had a tumor and died. So it's very sad, but I drew these panels. This is to commemorate her big theorem that related symmetry with the conservation of energy and helped Einstein to solve one particular conundrum in the run-up to the theory of relativity. This is about conservation of different forms of the different physical concepts. This one was to commemorate the idea of community and how mathematicians don't work by themselves in isolation, but everybody, and nor does anyone else, everybody works as part of a community. And finally, this is a fractal to commemorate and remember the struggles that Noether went through to live her life, to try and live her life, and then was never really able to be free of them because she ended up dying of the tumor. So that's a whole other story, but I wanted to talk about the math behind this particular piece, which is very geometrical, but it then led to some social justice questions that I had not even thought that it would lead to. So the shape in the middle of this is a four-dimensional cube, and I'll come back to what the shapes at the bottom are. The shapes at the bottom are 4 pairs of parallel three-dimensional cubes inside there. So what on earth does that mean? Well, to make a four-dimensional cube, let's try and understand how we make a three-dimensional cube. To make a three-dimensional cube, you take 2 two-dimensional cubes and join them up with lines. So if we go up a dimension, we can make a 4-dimensional cube by taking 2 3-dimensional cubes and joining them up with lines. So if you look inside the middle of this picture, there's a pink cube and a yellow cube, and they're joined up with blue lines. And here I would like to, I'll come back to what that relates to, but at the bottom of the picture, I've got 4 parallel pairs of cubes and some numbers and some multiplication written on them. So I want to talk about what that is about, because it says multiplication by 2, multiplication by 3, multiplication by 5, and multiplication by 7. And if you look closely at the first picture, it's got some numbers written in blue at the corners of the cubes as well. So what's that about? This is actually something that I have done every semester in the Elegance of Abstraction, when we talk about the factors of 30. And we talk about the factors of 30 in a way that's a little bit different from how factors are usually studied in school. So what I say is that, well, what are the factors of 30? They are the numbers 1, hello, numbers 1, 2, 3, 5, 6. They're all the numbers that go into 30, 10, 15, and 30. And so this is a bunch of numbers in a straight line, and it's not that interesting. And in category theory, what we do is we look at relationships between numbers. So the next thing we would do is say, actually, instead of just thinking about these numbers in a straight line, what about which numbers are also factors of each other? So I'm going to draw a kind of family tree, and I've got 30 at the top, like a kind of great-grandparent, and 6, 10, and 15 go directly into 30. And I'm not going to draw lines across 2 generations, because just like in family trees, you don't draw a line from grandparents to grandchildren, because you can deduce that through the child generation. So now here we have that 5 is a factor of 10 and 15, 2 is a factor of 6 and 10, 3 is a factor of 6 and 15, and 1 is a factor of 2, 3, and 5. So now we see that it's not just a bunch of numbers in a straight line, it's the corners of a cube, which I think is a bit more interesting than numbers in a straight line. And what we do in class is we explore different shapes that arise from different numbers and try and ask ourselves why this happens. Because in math, it's not just about getting the right answer. It's about why things happen, understanding how the visual structure relates to the abstract structure inside something. And what we find is that it's because of the prime factorization of 30. So you might not remember anything about prime numbers, but the prime numbers are the ones that are not divisible by anything except 1 in themselves. And 1 doesn't count as prime because you can't build numbers with 1 by multiplication. So you can make any number by multiplying prime numbers together. And so 30 you get by multiplying 2, 3, and 5 together, and that's called the prime factorization of 30. And in this diagram, I've written out the prime factorization of each number at the corners. And so you see at the top, the number is, there's only one number, 30, and that's got 3 prime factors. And at the next level down, everything has 2 factors. And then the next level, they actually are prime numbers. And the bottom is the number 1. And I've put this empty set sign there to show that that has no prime factors. And so then we can go one level more abstract. So abstraction is about forgetting certain details of a situation. And we can say, oh, well, it didn't matter that that was the numbers 2, 3, and 5. We could call them any A, B, and C. And we get this diagram. And sometimes people say to me, I was fine with math until the numbers turned into letters. But what I aim to do in the Elegance of Abstraction is to show what the point of abstraction is. And the point is that if you forget some details of a situation, say you go to the level of A, B, and C, then you can immediately apply it to way more things, because you can immediately say, oh, A, B, and C could be something else. They could be 2, 3, and 7. And if you multiply 2, 3, and 7 together, you get 42. Here are all the factors of 42. And this is the diagram you get. The prime numbers are at the bottom, the products of 2 prime numbers are next, and 42 is at the top. And we can draw the other diagrams back. The middle one shows that we've got the prime factors 2, 3, and 7. And then the one on the right is the extremely abstract version where we've gone back to the letters A, B, and C. And that shows that this really is the same. At some level, it's the same situation. And math is about finding abstract versions of situations so that we can say that different situations are in some sense the same, and that helps us make connections between them and study many different things at the same time to save our brain power. So this is related to the piece of art, because if we go up one more level, we will get a 4-dimensional cube. So this was a 3-dimensional cube because it had 3 prime factors, 2, 3, and 7. But if we had 4 of them, we would have, say, 2, 3, 5, and 7. And that was what was depicted in the picture. 2 times 3 times 5 times 7 is 210. And it makes this, which is a 4-dimensional cube. So how is that a 4-dimensional cube? Well, we take, here's the picture again. So you can see at the bottom level, I've got 2, 3, 5, and 7, showing the different directions in which you can multiply numbers inside the 4-dimensional cube. And what this 4-dimensional cube has is 2 parallel cubes. So this is a 3-dimensional cube and a parallel 3-dimensional cube, which we then join up with lines. And we could do it in 4 different directions. And each one represents one of those prime numbers in the 2 times 3 times 5 times 7. Now, my main aim isn't to fully explain that structure. So if you don't understand that, that's fine, because I just wanted to show you these pictures and show, in essence, how I was led from thinking about pure math to thinking about things to do with social justice by talking to students in class, basically. So those are the 4 pairs of parallel 3-dimensional cubes inside that picture. But coming back to the factors of 42, one day I thought, well, if A, B, and C can be anything, this is all very well, it's kind of fun and it's cute, but most of my students aren't very interested in numbers. A, B, and C don't have to be prime numbers, and they don't even have to be numbers. They can be any 3 things. For example, they can be 3 types of privilege, like rich, white, and male. And then in this diagram, at the next level down, we have people with 2 of those types of privilege, rich and white, rich and male, and white and male. And then at the next level down, we have people with just 1 of those types of privilege, rich, white, or male. And then at the bottom, people with none of those types of privilege. So I can put the missing words back in, and we have rich, white, non-male, rich, non-white male people, non-rich, white male people, and so on. And so this is now a diagram. It used to be a diagram of factors of 30, which is maybe cute, but not much to do with real life. This is now a diagram which helps me understand why people are so upset, angry, and willfully confused about the theory of privilege. Because this diagram shows, each arrow shows a direct loss of 1 type of privilege. And some people think that white privilege is claiming that all white people are better off than all non-white people. And that isn't what it's claiming. What it's claiming is that if everything stays the same about you, but you're not white anymore, hypothetically, then we would expect you to be worse off in society. That doesn't mean that every white person is better off than every non-white person. And so some white people point at some super rich black sports star and say, see, look, there's a rich black person. That shows that white privilege doesn't exist. But the point is that if that super rich black sports person were super rich white sports person, they would be even better off in society. And so this diagram also helps me to remember that the 3 types of people in the top level, rich white non-male, rich non-white male, and non-rich white male, have no arrows between them because there is no direct comparison between those types of people. And that can cause antagonism because if everyone focuses on the kinds of privilege they do have and forgets about if everyone focuses on the kinds of privilege they don't have and feels aggrieved about that, then they forget about the kinds they do have and then get angry when other people point them out. Another way in which this diagram helps me is because we can take any 3 types of privilege. And so instead of rich white male, we could change our context to thinking about, say, just women, and then we could think about 3 types of privilege among women, such as rich, white, and cisgender. And then we get an entirely analogous diagram, except now the people at the bottom with none of those types of privilege are poor, non-white, trans women. And we see that rich, white, cis women occupy the analogous position in this diagram that rich, white men did in the previous diagram. And if rich, white, cis women mostly only mix with white people, then they will only focus on the fact that they feel oppressed relative to rich white men. And they will forget how privileged they are relative to all these other women. And that causes antagonism. And finding these abstract structures helps me to empathize with people in different positions because I can find 3 types of privilege, A, B, and C, make a diagram, and depending on which types I choose, I can choose 3 that I have, 3 that I don't have, or a mixture. So I can put myself in any position in this abstract diagram and thereby empathize with people who are in all sorts of different positions in different diagrams. And it's a way that abstract mathematics has helped me to empathize with people and also to understand why arguments about privilege are so antagonistic. And this all came from thinking about category theory structures with students in this class at SAIC. Finally, I want to talk about art and propaganda, because this is what happened with my next art commission, which was from 6018 North and was part of the Living Architecture exhibit, which was an exhibit of immigrant artists focusing on different aspects of immigration. And I was specifically asked to do something mathematical, another chalkboard, something mathematical to do with immigration. So it started at 6018 North in Chicago. It then moved to the Lebesnick Center in Michigan City, and then it moved to the Chicago Cultural Center, unfortunately just before we went into lockdown, so it didn't stay up for very long there. But here it is at the Lebesnick Center just after I finished it. And here is a more close-up version of it. I will move the picture of myself so that you can see what's happening a little bit more in the corner where it says citizen. Because what I wanted to emphasize in this piece is the different ways in which people end up in the US, and the fact that really everyone is an immigrant apart from native people, and that many people are undocumented for different reasons, and that doesn't make them bad people, and that in fact the original people, the original people here are native people, and then white people showed up completely undocumented and colonized in a rather violent way. And then there were people who were brought here against their will, enslaved people, and that still happens. There are still trafficked people who come against their will. I wanted to show this is a mathematical tree showing all the different ways that people come here, and so that everyone can find themselves in this picture and find how they came here. I myself I came here over here. I am an immigrant. I am a documented immigrant. I came on a application of this strangely entitled extraordinary ability. I am not a refugee, and it's very dark up here. And I wanted it to be deliberately dark, as the place we're in now is sort of murky. But I am a permanent resident, so I'm not a citizen. There is a little route here that is depicting people who died on the way here, because I wanted to commemorate those people as well. So my main aim isn't to go into great detail about this piece, but I wanted to show it to you in order to talk about some reactions to it that I had. Because some dude on the internet said, that's not art, that's propaganda. And I thought about it, and I thought, well, what does that mean? And then my dear friend Gregory Peebles replied, well, all art is propaganda. And I ask students in the Elegance of Abstraction, ostensibly we're talking about logical statements, but I ask what they think about this. And some students think all art is propaganda, and some don't, and that's up to everyone. But Greg's point was that all art is making some kind of point, and all art is trying to convey a message. And if you're trying to convey a message, isn't that propaganda? Isn't all art trying to convey a message about society? And I think about that with respect to the math that I do as well, because traditional mathematics says that math should be neutral. That's what old-fashioned mathematicians say. Math should be neutral, it shouldn't be political, and I used to think that, and I used never to talk about politics in math class, and ask everyone to leave that at the door, we're just going to talk about math in the abstract world now. But I gradually realized through teaching at SAIC and talking to students here that actually I don't believe that anymore, because what I think is that there is no neutrality. It is not possible to be neutral when people's lives and people's well-being and people's belonging, when people's lives are on the line, there is no neutrality. And if I ask students to forget about social and political questions when they come into my classroom, if those are the things that are affecting their life all the time in the world, and I ask them not to think about it in math class, then all that's going to happen is I think they're not going to be interested in my math class. And if I ask everyone to leave those questions at the door, then I am inherently favoring the people who don't have to address questions of well-being in life so much, and therefore I will always be favoring cis, straight, white men, especially the rich ones. And so I think that in some things it is not possible to be neutral. There is no neutrality when it comes to racism. You can't be neutral about racism. You are either anti-racist or I think you're not doing well enough. And there is no neutrality when it comes to things that you take a moral stand about. So I don't think that I don't feel any compulsion to be neutral about murder. I'm anti-murder. I don't feel any compulsion to be neutral about rape. I think rape is wrong and that I don't feel any need to be neutral about it. And that is what I've come to realize, that all academic disciplines should be, in my opinion, working towards making the world a better place and should be taking a stand against injustice in the world. And so my journey has gone from being a fairly traditional, neutral, abstract mathematician, very removed from real life, to now talking about these issues all the time, thanks to the thoughts and the interactions with students at SAIC. So I'm very grateful for that. And that's really all I wanted to talk about today. So thank you for coming to my talk and for giving me a chance to talk about math, art, social justice, and about the fact that there is no neutrality. Thanks.
Hi, Eugenia. Thank you so much. So we'll be taking questions now from the audience in the Q&A section.
Yeah, you type any questions that you had or have into the Q&A or the chat. It doesn't matter to us. In the meantime, Yebit, do you have any questions to start us off?
Yeah, let's go off with the question that you had with the decolonization of math, Amelia. Do you want to go for it?
So, I mean, this might be a big question, but I'm going to go for it. You clearly think very critically about the position of math in the larger world and the way that it's taught. And you gestured to the answer a little bit in your lecture. So what does a decolonized world of mathematics look like to you?
It is a very difficult question. And it's a particularly difficult question because I need to recognize that I am part of the colonized view of mathematics, and I have bought into it because I am doing research in a field that is absolutely to do with the development of mathematics away from human culture in a way. And I've thought about this really hard because there has been a highly politicized and divisive argument about it. And I want to be measured and not just jump to conclusions. And what I think is this, that for me, colonization, and especially white European-based patriarchal colonization, is to do with a kind of movement away from our basic human connection with nature. And I think that it values a certain kind of development and construction. And I think this is true of a lot of the things that I really enjoy and value. This is also true of classical music, which is also very colonial and patriarchal and white European dominated. And it's definitely true of mathematics, the way that at least the kind of white Europe, now European driven, I'll come to the history of mathematics in a moment, but it's been driven by development of thinking that is kind of separate from what you might call natural human instincts. And there's another part of mathematics which is currently called ethnomathematics, which I have had some heated arguments about that term, because to me, I have been called ethnic by white people. And so I have residual sort of past pain from being described as an ethnic person. And of course, we're all ethnic. Whatever our ethnicity is ethnic. And so to me, ethno, stuck on the beginning of a word, is usually objectifying and patronizing, and it's treating people as a monolith. But I was criticized for criticizing the term ethnomathematics because it sounded like I was criticizing the study of ethnomathematics, which is not what I was trying to do. And I think the idea of the ethno prefix isn't to do with, it's not deliberately to do with non-whiteness, but it's more to do with the connection of mathematics to culture, as opposed to the development of it away from culture. And I'm starting to see that the values of colonialism and all that are to do with developing things away from basic culture. And I think that there is value to that because, for example, we wouldn't be able to have this conversation without the technology that has been developed. But also there are terrible consequences to it. Not only, of course, the killing and exploitation of non-white people, but also the fact that we are destroying our planet, and that it is the move away from a connection to our natural roots that is causing the destruction of the planet. And that white colonial instinct or development is, I think, directly what is causing the planet. Now, there are other cultures that are doing that as well. And specifically, I have Asian roots, and I think that the Asian cultures, to some extent, are also doing that. But what we ought to be doing more is listening to native cultures who are very much better at living in balance with the planet. And but I think that doesn't mean that everything that colonial development has done is bad. I think that, but we need to acknowledge. So there's the other fact that mathematics is founded in non-white cultures. The history of ancient mathematics is founded in, there's Egyptians and Syrians and Arab culture and Indians and Chinese, and even what we call ancient Greek mathematics. And I was called out on this recently, and I acknowledge that I didn't understand fully that when we talk about ancient Greece, when we don't mean ancient Greece, we mean a Greek empire, and that's a colonialized attitude to empire, where we generically refer to everyone in that time as Greek, although most of them weren't Greek. They were just part of the Greek empire. And so some of the mathematicians we call ancient Greeks were some of them were definitely not Greek because they were from Syria or Egypt. And some of them we just don't know quite where they were from, because so much of the knowledge at the time was based in Alexandria, which is in Egypt, which is part of Africa. And I think it's important to acknowledge this, especially because there are racist people now who think that, for example, Africans are less intelligent. And this is obviously untrue if you take into account, well, first of all, it's obviously untrue because of what science has discovered recently, but also we should acknowledge that the whole roots of all of our intellectual development come from studies that were in non-white parts of the world. So I think it's obviously, as you say, it's a big question and it's complicated, and I don't claim that I do everything right all the time, but I still do value the development. The music I love is really based in extreme quantities of development away from what you might call natural instincts, and it's things that you have to develop by huge quantities of technique, and I love that and I am excited by it. And I don't think that makes me a bad person, but I think that we need to acknowledge the people who have been exploited and erased on the way towards that. And I don't know what the entire solution is, except to keep thinking about it. At least we should keep thinking about it.
Thank you.
I think that Anna has a question. Was there a specific event that you remember that caused you to turn towards incorporating social justice into mathematics?
Thanks. It was definitely a progression, and it was definitely inspired by all the students who took the first few iterations of my class, The Elegance of Abstraction, and it continues to be inspired by all my students, including Amelia, who take my class, The Elegance of Abstraction, because everyone brings such deep and varied personal experiences into the class. It's always such a wide range of cultural and family and life experiences. And I am so grateful that students in the class are so willing to share those experiences and discuss them and bring them into the mathematical discussion that we're having, because it enriches my experience and it enriches everyone else's experience. And so definitely that process of wanting to develop the way I teach for the students who are in front of me. But honestly, if there was going to be one event, it was the election of 2016, because during that semester, it was just, I couldn't not talk about what was going on, just like this semester and in every semester since. In fact, it was too important not to talk about it. And really, the morning after that election, I sat down and I thought, this is the most important thing that I can do at the moment. And actually, I was also inspired. I was very inspired by a physicist called Professor John Byers, who does a lot of outreach work. And he, at one point, sat down, examined his life, and decided he should switch basically switch from being a pure mathematician to working on climate science, because he decided that was the most important thing he could do with his expertise. And one thing he said, he gave a public talk that I organized in the UK, and he said, what can pure mathematicians do? And he said, one of the things that pure mathematicians can do is teach math better, because that will help everyone's understanding of science and everyone's understanding of what we need to do. But he inspired me to that, but he also inspired me at a meta level, which was that one should always examine one's own abilities and unique combination of expertise and decide how you can use those things to make the best contribution you can to the world in the way that you see fit that's most important. And after that 2016 election, I thought that the most important thing I could do was try and contribute to the clarification of these divisive arguments that we have. And so then it became that was definitely if not a turning point, it was definitely a kind of cementing point.
It looks like we have a lot of questions coming into the chat. I don't know if we have time to answer all of them, but we can go in order.
Well, why don't you pick things that you think are really interesting? Because it might not necessarily be, when one does raised hand question time, the people who shoot their hands up first, classically we give them precedence, but is that really the right way to do it?
Well, you're right. One of these questions that I see that kind of raises another question for me is you get a lot of pushback on a lot of your ideas and a lot of the things you say. How do you go about dealing with people who are being closed-minded, or in your words, congressive?
Right. So I try to be congressive about it. And the first thing is, and I had an interesting discussion with someone on Twitter about this the other day, that it's a kind of a mistake to label people as closed-minded, because most people don't see themselves as being closed-minded. And I try to remember how people see me, and that sometimes people think I'm closed-minded. And when I think about it, I can see why they think that, because I have strong opinions, but I don't feel closed-minded because I feel that I have arrived at those opinions through some framework of thinking about stuff. And so, for example, I have very clear taste in music, but I also have reasons for it. I can actually articulate what my reasons behind that are. And so when I am interacting with people who, let's say, just disagree with me a lot or give me pushback, I first try to understand why they think that. I think it's a mistake to try and persuade people to change their mind immediately, because that's making an assumption that you're right and they're wrong, and that's never going to work. Because what happens if you do that, if you try and persuade someone to change their mind, typically what they do is they entrench themselves further, and the harder you try and persuade them, the more they dig themselves in. And the more reasonable you are about trying to persuade them, the more unreasonable they have to be, because there's nowhere left for them to go. Like, you're really pushing them into a corner. And I like to say that sometimes people might change their mind, but it's like changing your clothes. Most people don't want to do that when someone is looking. And so instead, I try to reach an understanding instead, and try to enrich my own understanding, to just try and empathize with them and see where they're coming from. And sometimes if it's in person, then I feel I can do that much better. And I think this comes from, or is related to, how I view teaching, especially teaching mathematics, and especially teaching mathematics in the traditional way that I used to have to do it, where we were really trying to get students to do things right. And now when I teach it, there's less of a kind of, this is right, this is wrong. And so if a student did something that was, as it were, wrong, then it doesn't help if you just tell them it's wrong. And it doesn't help if you tell them the right way of doing it. You have to understand why they did it the way they did it, and why they thought that was right, in order to understand what you need to do to morph that into a right way of thinking. And so starting out by just telling someone what the right way to think is I think, worse than futile, because it's probably going to make the situation even worse. So I try to understand, and often I really can understand, and I don't like it when people say, I just can't understand why anyone would think such and such, because I can always understand. But sometimes I'm curious as to which of the 15 ways that they could have reached that conclusion, which one is it actually? You know, which version of disagreement with me are they having? It's like if I say that Black Lives Matter and people say all lives matter. And so there are various things they could be saying. So I think Black Lives Matter means that Black lives matter just as much as other lives, that they are currently treated as if they are not, and that we should do something about it. So if someone disagrees, it means that either they think that Black lives don't matter as much as other people, in which case they're really terrible people, or maybe they think that Black lives are currently treated just as fine as other people, in which case they're ignorant or delusional, and maybe they think that we shouldn't do anything about it because that would be like reverse racism, which I don't think is a concept that exists. But anyway, it can be helpful to figure out exactly which kind of disagreement they're having, just to understand what kind of thing it is. Otherwise you just yell backwards and forwards, Black lives matter, all lives matter, Black lives matter, all, and then no one ever gets anywhere. So when it happens on social media, which it does a lot, I try not to engage too much, but I try and engage one time, and I will engage with everyone one time and try and gauge what's going on. And after that, then no, because I would rather spend my time on people who are showing willing. So if someone is showing willing right from the start and is not being disingenuous and wants to be kind, then there are too many people in the world, and I would rather expend my energy on those people, and also the people who it is my job to help, which is my students. And so I would rather save some time. And I think we're all very exhausted by the world at the moment, and there's a limit to how much we can all do. And I quite often push myself way beyond those limits and get too exhausted. And I'm still learning that it's important to set those boundaries and look after myself as well. And I think that's something for everyone to remember, especially non-male people and non-white people who are always under more pressure to do the work, to fix things in the world. And non-male people are often under pressure to look after everyone before themselves, that's considered to be the noble thing to do. And it's a self-sacrificial thing to do, and it is portrayed as being noble, but it's often not helpful, because if you wear yourself out, then you won't be able to help anyone, actually. So I try to engage a little bit, but also protect myself.
So wise. Thank you for sharing your wise words, Eugenia. And I believe we're near the end of the hour. So thank you all for joining us this evening and for following our ATS X ANAH series. Please be on the lookout for ANAH's Spring 2021 talk series. And you can subscribe to our newsletter on our website, arthistorians.net, which I put in the chat below. I also wanted to share with you that we will be hosting the Intercollegiate Art History Symposium. The submission deadline is January 1st, 2021. Stay safe and be well, everyone. Thank you so much for joining us again. Bye.
Thank you. Bye.
Bye, everybody.